So here's a couple more examples of integrals involving sine and powers of sine and cosine that maybe won't be quite as straightforward as those first two examples that I showed you. Same rule of thumb applies though. Focus on odd exponents. So you look for the trig function with the odd exponent and you break off one power and you use it to form your differential du. So in this case, all we see is a trig function with an odd power, so there's no decision making to be done here. So we can just break away one power from this sine cubed of 2x and express this as sine squared of 2x times sine of 2x to the first. Now, remember, so when we break away that one power, that's where we're wanting to build our differential du. So if du involves sine of 2x dx, then u would be cosine of 2x. Now here's the thing. I wouldn't necessarily just integrate this to decide what u is equal to. It's more natural to let the du carry whatever multiples. So if there's like a negative that you need, or a 2 in this case, it's more natural to let the du carry that multiple. So I tend to favor, so if I see du involve sine, then I know that my u will involve cosine. And we call this the argument, whatever's inside the trig function, keep that the same, keep the same argument. So cosine of 2x. If u is cosine of 2x, then du is the derivative of that. I guess I'm going to stick with red. Which is, let's see, so derivative of cosine is negative sine, leave the inside alone, times the derivative of the inside, so times 2 dx. So du is actually negative 2 sine of 2x if u is equal to cosine of 2x. So rather than integrate this and put a negative 1/2 here, is what would end up happening, I favor saying, okay, so I'm just going to multiply by negative 2. Multiply by negative 2 here. That way this is equal to the differential du. And this is legal as long as we multiply by the reciprocal, so negative 1/2 out here. Because notice that what I've multiplied by then is actually, so say I bump this negative 2 outside, like you've seen that I like to do. Then you'll have negative 2 over negative 2, so positive 1 as your coefficient. And so this is equal to the original integral when you do this. So if what you need is a constant multiple to get this expression to match your du, then what I like to do is just go ahead and multiply that by that, put the reciprocal out front. So that this becomes negative 1/2 integral of, well here I'm going to leave it, let's leave it this way for now. Sine squared of 2x times negative 2 sine of 2x dx. Okay, which again, we know that this right here is du. U is equal to cosine of 2x. Okay, so I'm supposed to take what's left right here, this sine squared of 2x, and write it completely in terms of u. Because that's what, when you integrate using a substitution, what you want, so your goal with these integrals is to have some expression of u, times du, right? That's the goal. Function of u times du. Then we can integrate it. Where in this case, u is cosine of 2x. So here's your du. We want this to be written in terms of u, which is cosine. So remember, sine squared is equal to 1 minus cosine squared. Keep the angle the same. And so that, if u is equal to cosine of 2x, this is equal to 1 minus u squared. This right here, everything in the box there is equal to du. And then we still got this negative 1/2 outside. So what we're looking at now is the integral of just 1 minus u squared. I got to close that blind the rest of the way. I leave it up a bit for the dog to look outside, but he'll have to not look outside for now. Okay, so we've got negative 1/2 times the integral of 1 minus u squared du. So now we could just go ahead and write the antiderivative. So that's negative 1/2 integral of 1 is u, integral of u squared is u cubed over 3 plus c. And so final answer, I'll distribute the negative 1/2 while I'm at it here. So that's negative u, which is cosine of 2x, over 2. This times this will be positive u cubed, so cosine of 2x cubed, over 2 times 3, 6, plus c. And that's cubed. That's cubed right there. There's your final answer. Okay. Now I want to look at the second integral. So the integral of cosine cubed over square root of sine of x. So one thing that might catch your eye with this integral is the fact that you've got sine of x under the square root. So typically when you've got one function inside of another one, a lot of times in that scenario, we'll let u equal the inner function, sine of x. Maybe based on this, you might be inclined to think in those terms. But looking at this another way, if you're just in the where's my odd power of either sine or cosine, and you look at your cosine cubed and you say, okay, well then I know, I'll rewrite the problem over here, that we should break one power away from that cosine cube. Since I'm rewriting it, I'm going to color code this. So I'll leave this here, but this cosine cubed here, if it's the odd exponent that catches your eye, that's also good. So break one power away from that. So write this as cosine squared times cosine to the first dx. There, let me get rid of this. Okay, and where we say, okay, so this is where I want to build the differential du. So if du involves cosine, then u is sine, which is what we were thinking anyway, or what I was suggesting based on the fact that sine is the inner function here. Okay, so our plan is to integrate with the substitution u equals sine of x and du equals cosine of x. So this one's straightforward. We don't need to multiply by -2 or anything like that in this problem. Just we have the straight differential du already handed to us. And so now we can write this in terms of u. So in the denominator, it's just square root of sine x, so that's square root of u. This whole cosine x dx is du. Okay, so cosine squared, make a note over here, is equal to 1 minus sine squared x. And so that's equal to, if u is sine of x, then this is 1 minus sine of x squared, 1 minus u squared. So now we're looking to evaluate this integral here. Let me get rid of this. It's from our last problem. Okay, so now you got to think about, well, how do I handle this? If you have two terms in the numerator like that, a sum in the numerator and a single term in the denominator, what you might do is split this up. And then I'm going to change from writing this, expressing this as square root of u, I'm going to express it as u to the 1/2. And then minus u squared, again, over u to the 1/2. So I'm breaking up that fraction. Now remember your property of exponents that says if you have x to the a over x to the b, then you should subtract those exponents, x to the a minus b, in order to simplify this. So here, u squared over u to the 1/2 is u to the 2 minus 1/2, which is 4 over 2 minus 1 over 2. So this is going to turn into u to the 3 over 2. And this part in front we can write as u to the negative 1/2 minus that du. So I'm going to go ahead and close this blind. Sorry, guys. And so now use the power rule to write that antiderivative while you listen to me closing my blinds. Sorry, I'm using really rudimentary video making here setup, so I can't even pause. Okay, so power rule, add 1 to the exponent, you have u to the positive 1/2, divided by, well, okay, I'll write it, over 1/2, that's a 2, minus, add 1 to this exponent, that's 5/2, so over 5/2. I typically won't write it this way. You may have noticed that already. Typically, instead of, here, plus c, instead of dividing by a fraction, I will go ahead and multiply by the reciprocal in most cases. So this right here, I would typically express it as, instead of divided by 1/2, that'd be 2, u, which I just erased, but it's sine of x, to the 1/2, which if you want to write that as a square root, that'd be fine. That'd be good. Again, instead of dividing by 5/2, I would multiply by the reciprocal, 2/5 u, which is sine x, to the 5/2 power, plus c. So it's fine to just box that up. That's your final answer. If you're wondering, so yes, certainly this 1/2 power you could write as the square root of sine of x. The 5/2 power, if you recall, you should interpret fractions in the exponent as power over root. So this is 2/5. It's a square root of sine of x to the 5th. And when you look at it that way, you might even factor out square root of sine of x. But I'm going to stop there. I mean, that's enough simplifying.